Hey everybody,
Hi.
I'm glad folks are here. I didn't know who was gonna show up today.
You afraid you'll be sitting here alone?
Yeah, well, if I was, I would have just still recorded myself doing some coding. I do a little bit of housekeeping here on the agenda. Um, does anyone in here have stuff they want to talk about? Because if not, you have to watch me live code. Tread carefully.
Live code, live code, live
Okay.
code.
If you guys don't say stuff you want to hear or see, I'm gonna live code like every single week, just so you know. And it might even get worse. I might post these onto YouTube. Actually, I'm going to post these on YouTube.
Hey, I think you're obligated contractually.
Yes, I am.
But I think, at least for my sake, it's watching other people's code, and at least if you explain what you're doing, that's very nice, because then we can see actually how people are doing stuff instead of we sitting here making all the errors by ourselves and figure it out 3 years after. So
Yeah.
I think it's, for me, it's very good.
Oh, you know what? That reminds me. We do some live coding, or not live. We do some screencasting for the Athens project that I work on. So I'm going to go find the link to that playlist real quick, and I'll put it into the agenda. So give me 1 second. YouTube.
Aaron, with your new microphone, when you type, it's like God is typing.
I know. Sorry. I still have to get like this thing is on my desk, so it's like right next to the keyboard. You can hear that. I have to get like a boom or something.
I thought you were saying that to me, Caroline. I've entered a few meetings and forgotten I wasn't on mute, and then gone bang, 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 bang.
I mean, I'm used to the mechanical keyboard sound, but because of his microphone, it's this condenser mic. It's picking up just like the reverb through the table too, and it just sounds extra forceful.
What table do you have, Aaron? Oh, by the way, there's also a preferences thing I just discovered the other day. So you go Zoom preferences, and you can actually mute microphone on joining. So that's a good sign.
Oh, yeah, I should do that. All right. Does everybody have the link to the agenda? Anyone want me to put it? Okay, cool. I moved the microphone a little farther away from my godlike keyboard, so cross your fingers. I am going to close embarrassing things on my screen, especially my text messages where I am complaining to people about various life things, and Spotify where I'm listening to Taylor Swift.
Say Tyler.
And let's go over. All right, I can share this. I'm listening to Taylor Swift. All right.
There's no shame in that, Aaron.
Yeah, there's no shame. I know. All right, we're going to pick up a PR that I have been working on inside of that Athens project, which is, here we go. No, not that one. This one. So this one is about testing, and there we go. So the issue is here, add tests for the proxy routes. So before I get into the code, the proxy inside of this project is basically a Buffalo web app. And just like any web app, it has a bunch of different routes. So the point of this thing is we want to add tests that actually exercise those routes to make sure that when we pass some X data in, we get Y response back. And ideally, we want to do that without having to like spin up an entire web server and on one process and then make requests to it from another process. And Buffalo gives us a really nice way to do that built in out of the box. And it's kind of sort of similar to the facilities that Rails gives us, but we get to ready and go, which is pretty cool. So here, going back to the PR, I'll show you what I've done so far, and it's really, really Spartan. So here is a test called test list. This isn't the same as what Go built-in testing library is. This is a library that layers on top of that library called Testify. There's a sub package in Testify called Suite. And as the name implies, it lets you write Go tests kind of like they're part of a test suite. So it looks a bit more familiar to like the Java test suites, or PHP is a nice test suite library as well. So going down here, I'll skip over this for a second. This is making a request to this URL with a content type to get JSON back. This is executing the request using the get HTTP method. And then we're doing our extensive verification of the response by making sure that it gets a 200 back. So we're going to have to add more, obviously. Just asking or just making sure we get a 200 back is not ideal. We probably want to check for more. Below, this is to improve like running tests locally. But this isn't going to be like the focus of this PR. So I'm going to open up the Trusty terminal. How loud is this?
Godlike.
It's still godlike? Ah. All right. Next.
Own it, dude. Own it.
Yeah. Next week I will probably not have anything better, but I always dream. Let me make sure this is updated. It is not.
Is it okay if you zoom in a little bit on your screen?
Absolutely. Better?
Thank you. Yeah, perfect.
Same thing here. Is that better too?
Yeah.
All right.
So I believe it would look weird if I looked like right into the camera all the time to watch what you were typing.
Yeah, that's no good to crane your neck either. Oh, do people know about this update branch button in GitHub? People seen that before?
Only on projects that you admin.
Yeah, I just discovered it. So if you create a project in GitHub, a repo, if you administer it, you can press update branch, and in the background, it'll like grab everything from master and it'll merge it into your branch. And if there are going to be conflicts, this button will say resolve, and it'll actually open up a little UI in GitHub for you to like, if you can, it'll let you resolve all these dependencies without ever opening a terminal or installing Git or opening VS Code or any other IDE. I love it. So I pressed it just now, and now in my terminal, I can git pull and it'll get all the stuff back down from master. Just like that. I don't have to do any other command line gymnastics. I like command line gymnastics, but I don't have to use them in this case, and that's pretty cool. So let me just size this up a little bit better. Cool. All right. So we were up here inside of CMD proxy actions list underscore test. Okay, so when we make this JSON request to /list, what we're expecting, this is a detail of the protocol, the REST API specification that we're testing. When we make this request, we expect to get something like this back. It's a new line separated list of versions. So it'd be like v1.0.0 and then v1.0.1 and v0.0.2 and whatever other stuff. it's an implementation detail that this list should be ordered by semantic version. So like this thing would go up here, and then it'd be like the most recent version down to the earliest version. But we're not going to assume that in this test, so we're just going to do that. We're going to assume like it could be in any order, but it always needs to return the complete list that we expect. Okay, so I'm going to leave that there. Going into some details of the test suite, if we go check out Action Suite, this is a struct, and this is like the central, let's call it like the central test suite. It's like a collection of all of the shared state in the test suite. So it embeds suite.action, and that is a Buffalo facility. It's a Buffalo package that is based on top of Testify's suite. So I'm going to just go in here real briefly. This is inside of Buffalo. This is one of our dependencies. Action then embeds like Buffalo sessions. This is a REST API testing library. It embeds app, and app is our web app. It embeds some private thing that deals with CSRF. And then model, it embeds model. Model is another Buffalo test suite facility. And model has these things called assertions in it, which are things to check expectations and tests. It has a database for us to mess around with. We're not going to mess around with it today, but it's super useful because if you're writing a database-backed web app, you can like shove some stuff into the database and call an endpoint, and then make sure that the endpoint returns the stuff that you just put into the database. So that's pretty nice. And then the thing of the hour is suite. So this one is actually here. This is the Testify suite functionality. So for this one, I'm going to actually go to GoDocs and show you all the things it can do. So tons of great docs in here. There are some good tutorials on the interwebs about this. So I'll put those into the agenda later. But basically, this is the best paragraph to read. You can implement any of the interfaces. You can make your test suite, but you can also do setup and tear down stuff. And methods in the test suite have to begin with test. And that's familiar if you've ever written tests for the Go standard library testing. And if they don't begin with test, then they're not going to be run. And they can be used as helper methods, or if you never use them, they're just nothing. So here is a great example of test setup and teardown. Okay, so setup test is a method defined on your test suite struct. So for us, that's going to be called Action Suite. And setup test is run once at the beginning of every single test. Okay. And then this is test, right? This is called test example. It is a single test inside of the test suite. And setup test is going to be run once before that test. Okay, and then there's this entry point down below. And this thing is a Go standard library test. And what happens here is Go will call this when you run Go test. It passes in this testing.t, which is like the entry point for all of the API to do testing. And then you just call suite.run. You pass in t, and then you pass in the instance of your struct. And then suite.run uses this package to just run through all of these things. It does all the setup and tear down, and it executes these tests and does everything. Okay, so one last thing to look at. Before test is the interface. Setup test is the interface that you can implement on your struct to execute before each test. And you saw that above in the example. And then teardown test suite has the exact same thing, but it executes after. So teardown test, setup test, those are the two things we can use. Okay, so I'm going to go back into our code. We're going to shut down some of these tabs because they make me crazy. So in our code, this is the Go testing, the Go standard library testing package compatible test. So here we're creating our web app, we're creating our test suite, and then we're calling suite.run. Okay. So going back to here, we have this kind of database thing going on, right? We have to put into some database some stuff, some versions that this thing is going to extract out when we do the test on it. And then we're going to make sure that it returns that new line separated list with the versions that we put into the data store beforehand. Okay. So we're going to have to spelunk a little bit down into here to figure out what that data store is. Okay. So we called app in here. I just clicked through to the definition of app. And here's where we get the storage, right? So that's important for us because in order to put stuff into storage, we got to figure out what the actual storage is. Okay. So here we're doing storage type is by default, it's memory. Actually, Carolyn just made this memory default a couple days ago, maybe Friday, I can't remember. Carolyn, do you remember?
I think it got merged on Tuesday.
Tuesday. So that's actually super useful for my purposes because it would be great for me to be able to run these tests without having to start up like a MongoDB or any one of these databases, or having to worry about writing stuff to disk, or having to have like cloud storage like Minio. Definitely don't want to start up like a cloud. This thing has support for Google, Amazon, and Azure clouds, even though we don't have them in here yet. So like all that stuff is a huge pain for me to have to set up and test. But what's really cool is I can just use memory. So the test spins up, writes a bunch of stuff into memory, test gets torn down, all the memory disappears, great. I don't have to deal with that. Okay. So here's where we get our storage. And we're going to go all the way down here, and we pass that storage, that is a backend dot storage. We call add proxy routes. And add proxy routes, I jumped into here. Add proxy routes calls register handlers. And register handlers now goes into a different library inside of the Athens project. And this is the endpoint we are trying to test. Okay. So it's whatever some module /@v/list. Okay. So then list handler is in here. And list handler goes all the way down here, blah, blah, blah. It does a bunch of just tracing stuff, grabs some stuff out of the path. And then finally it calls .list, right? So this is, if we go into here, this is what we're trying to test. I'm going to go click through here. The actual implementation of this interface is down here. And we're calling through to another .list. Oops. We're calling through to another .list, which is this, which we don't have enough layers of abstraction, right? So we're calling another .list, and this is where the magic happens, okay? So we don't really have to understand everything here. It's just that down here, we get a bunch of stuff back out. We JSON decode it back into this. And if I can go back, oops. We JSON decode it back into this list response, which looks like that. Going back to where we called .list, we get that list response back, and we return .versions. That is a string slice. Going back one stack frame up, a few stack frames up actually. This thing is just returning that same string slice. And then going back to here, we're getting back that string slice here of versions, you can see it. And then we're just calling strings.join. We're joining it with new lines, and that is where we expect to get our new line separated list. Okay, so we went through a ton of different stack frames. That's all good and great and everything. But what we've got to do is be able to figure out how do we put stuff into storage so that list gets back the stuff that we expected into storage. So here's how we're actually going to have to make some changes to our code. Okay, so I'm going to go all the way back to where we created our app. And this is one level below our app. Remember, our app is what calls add proxy routes. So we pass in storage to add proxy routes, okay? And storage then is passed into this thing called download.new. Download.new returns this new thing called a protocol. So really what we've got to be able to do is we've got to be able to pass storage, our own storage, into add proxy routes. And since app calls add proxy routes, it would really be great to be able to set the storage that when we pass into app, we would like to be able to set a storage on the app, okay? So I actually don't know how we're gonna do this, so we're gonna mess around with some stuff and see what we can do. Everybody ready? Anyone not ready?
I'm excited.
Okay, does anyone see a solution to this before I go and, I'm sorry I interrupted you, Karen. What do you say?
I'm waiting to see you use dependency injection.
Oh yeah. Well, does anyone have a solution before I go and start flailing around? I was hoping someone did. Okay, so here's the first thing I'm going to try. I'm going to put a storage parameter into here. And I think this is storage.backend. I think this is going to be a mess, but let's just see what happens. So I'm going to say this. Store, and I'm going to just remove that, remove that as well, and I'm just going to do this so that later on, like right here, people can define, they can assume that an error already existed. Not sure if we need that, but whatever, I'm just going to do that. Okay, so this function app is used like everywhere. And nowhere passes the storage right now, so I'm pretty sure this is going to be crazy, and we're going to get a ton of compile errors. But let's just go with it for now. Let's pretend here that we can actually define the storage, and we're going to pass it into app. So we're going to do this, store back, let's see, what is it called? I think it's storage.backend, yeah. And storage is this package. GitHub.com, Gomaz, Athens, PKG, storage. Okay, so that's this, storage.backend. And down here, we're going to create a memory, what is it called? I'm going to head down to that package. Here's storage, and under the storage is mem. And under mem, there's a mem.new storage. Okay, so we are also going to import this package, storage/mem, and it's new storage. And we've got store and air. And since this is a standard Go testing, Go standard library testing function, we're going to do this. If air is not equal to nil, that means that for some whatever reason we couldn't create a new storage. We're going to do t fatal f couldn't create a new in-memory storage. And then we're going to actually print out the error there. Okay. So what this is saying, for those who aren't familiar with the standard library testing, this is just going to kill the test. And that means that none of the suite is ever going to execute if we, for whatever reason, couldn't create new memory storage. And then this, I have to do that. Mem, not memory. All right. So after line 20, this whole deal, we now have a storage that we can work with. So first thing we got to do is pass it into the app. And the second thing is so that like the functions in our test suite can actually use the storage to like put data in so that they can test the stuff that comes out. We're going to put it into the actual suite so that list test and all the other functions that we're going to write can actually access it. Okay. So for Action Suite here, we're basically just going to do this. I'm going to clean that part up, right? So this is saying that this embedded thing is going to be a suite.new action. And that was there before. I didn't really change any behavior there. But then here, this is the thing that lets the test actually get access to the storage. Okay, so I did a bunch of spelunking there. I broke a ton of stuff, but at least for now, while we're writing our tests, we can access storage. And we're going to burn a bunch of other bridges later when we have to actually run the tests to figure out, like, hey, we got a million different compile errors because the function signature of app has changed. There's going to be a bunch of bridges to burn there. And maybe this isn't even the right way, but hey, live coding, I'm going with it. Okay.
Quick question. Are there other things down the line that we might want to test aside from storage? What are Athens dependencies beyond storage? And
probably. Let's go back to app and look. So we've got storage. That's here. This is kind of like dependency injection because storage is an interface and we've got a million different implementations. Context maybe, but this is basically the main. Like main, the actual main just calls this and that's it. So this is basically our main, and context, this is like the root context, so probably not. Filters are business logic that decide, like, does this dependency actually, should this actually get returned or is it prohibited? So that's probably a good candidate later. Background workers, that's another one. I think by default, these are Redis background workers. But for testing, we probably would want to make them, at least for most tests. For business logic, we probably want to use memory. Logging, I'm not sure. This is the actual Buffalo app. Probably not, because this function is trying to make one. Distributed tracing, maybe, not really sure. And then the routes. So like the general way that I go is like, I've broken a ton of stuff here and that sucks, but the compiler will tell me what I've broken. And so I'll go and add like, okay, this is one of the dependencies I need to mess with in my tests. Okay, great. So I'm going to add it here, let the compiler yell at me a bunch, and then I'm going to go and use it in my tests. And then later on, when I want to start, let's say, testing out the filters, I'll just do the same thing, and I'll add filters to here, to this function, this parameter list, and then I'll let the compiler yell at me all over again, and just keep going ad nauseum. Did I make sense?
Put those on a struct? Might you put those on a struct or something that you can then build up later and add additional things and keep the same?
Yeah. So I've done that before, and I basically do that like using the struct as a bucket of dependencies. And it's literally, I just do that so that the parameter list doesn't get too long, and like no other reason. I could see maybe some in the future, but like right now, I do that for just that reason, just to like condense stuff down. But yeah, maybe there's reasons later, like if you want to maybe take some environment variable configuration and grab something out of the struct, like the right storage or something along those lines. Cool. So let's go back here. Now we've got access to the storage. Okay. So let's check out, let's actually go to the definition for store, for the storage, and see what we can do on it. So we're going to go to the interface for storage, and I think it's in here. Yeah. So what was this again? Store was a storage.backend. This is what it is. So that's cool. This doesn't really tell us anything. It's a composition of a bunch of other interfaces. The one that we're testing is Lister, right? When I went down that stack through all those abstractions, eventually it calls list, passes in a context and a module. And you can see the Godoc there turns all the versions, or if it's not found, it returns an error. Okay, so that's cool. We go down to getter. This gets back like various pieces of information about the dependency. Checker, we're not going to use this either. Checks to see if it exists. Saver, we're going to use this to like stage our versions. This doesn't have Godoc on it, which is not great, but this is what we're going to do. We're going to use this to save a bunch of modules and versions into memory so that when we call that endpoint, it calls list and it gets them back out. And then deleter does what it sounds. We're not going to use deleter, at least not in this individual test. Okay, so let's go into Saver and keep this around so that we remember what's going on with it. Okay, so first things first is we're going to start creating some modules, all right? So let's do this. Module 1 equals, let's just work with one module for now. Call it mod test. Okay, so we've got the module, that's the name. We obviously want to test a bunch of different versions, so we are going to have a bunch of different version names. Let's just take these ones. I'm going to just put them into a string slice. Put them all, make them actually all strings. Okay, so the idea here is we're going to kind of do a table-driven test, sort of. Eventually, we're going to start looping through these versions, and we're going to save each one. Okay. So the other thing we need the actual the go.mod metadata. This is what the actual source code for the module is, and then there's another bit of metadata that has more information about the version of the module. We just happen to know, though, when we looked at that list implementation, we happen to know that really the only thing that we're going to care about is this. So let's say we save module for v1.0, v1.1, and v1.2, right? Really, it doesn't matter what we pass here because we know about the implementation. We know that it doesn't matter what we pass here. It really just matters what goes into here. Now, like, this is not TDD, right? I already looked at the implementation. I know all about it, and I know that like I don't have to pass these things in. I can pass in a bunch of nils. So this is not a great practice, right? We should actually be passing in all of the stuff and at least acting like we have no idea how the implementation works. Okay, so let's actually do that. Let's go full bore and do the whole deal, everything, okay? So going back to here, we know that we have one module that we're gonna try and test, but all of this stuff is gonna be different. We want a bunch of different versions of these. So here's where we're actually going to create a struct, and we're going to have a slice of that struct. Okay, so let's get fancy here and create an external, another struct. So let's just call it test case. And then I copied all of that highlighted stuff, and I'm going to paste it into here. Copy and paste. There we go. So these are going to be fields of the struct. Version, mod, zip, and info. So now what we're going to do is we're going to go versions equals a slice of test cases. Okay. So now test case 1, let's do this. Version is v1.0.0. And mod, let's just say it's bytes. 1, 2, 3. And zip. So we got to create an io.reader. I'm going to create a little helper for that. And I'm going to do this in a fancy, specific way. Get reader. So cool. So remember before, way back, when I looked at those docs for test suites, it said anything that doesn't start with uppercase T test, it won't be executed and you can use it for helpers. That's exactly what I'm going to do here. So this is just a helper function. I could have just taken this off, but I think it's cool to leave it on. It kind of shows that this is part of the test suite itself, and it's not like some other random function that anyone can call. So for this, I at least need to import IO because I'm returning an IO.reader. And how do you make an IO.reader that's completely in memory? I don't want to read from a file or read from the network or anything like that. Does anyone want to take a guess what I want to do here? Creating an IO.reader in memory. Don't everyone speak up at once.
Does IOUtil have something for us?
Let's go see.
I'm guessing. I don't know what I'm doing, Aaron.
Join the club.
I'm trying to help, man. IOUtil usually has all the things I want.
IOUtil. What's going on here? Did I not press enter? That's what happened.
There we go.
All right. IOUtil. There's an IO writer. That
So if we look at one of their examples, like read all, do they show us how to get something going from start to finish? Oh, look at that.
This is interesting.
Let's rip that off.
String reader. Okay. Should we check out strings?
I vote for that.
Okay. String.
I think we just disillusioned everyone because they thought we knew what we were doing.
I'm
just
just
going to be a
talking.
buffer or something.
All right. So what were we looking at again? New reader. So func new reader. Okay. New reader returns a reader. So we can pass in a string and get back a strings.reader. What is this? Hey, a reader implements the IO.reader, a bunch of other stuff. So this looks like a thing we want. Let's try it. So we're going to pass in string, or we're going to import strings. And let's do this. I'm going to go back and copy that example. Copy it, paste it in here, and then return R. So at this point, the Go plugin is going to, it actually already finished trying to compile this. Part of the compiler is checking, did R implement IO.reader? And it did, because this doesn't have a red squiggly line. So that's cool. Carolyn, thank you. You solved my problems. Do you have other, can I get you to solve some other problems for me too?
Always.
Okay. What should I do next? What is the meaning of life?
You know what? I feel like we've made a ton of changes. And if this were me right now and no one was watching me code, I would try to run go build and just figure out everything that I've left broken along the way.
Okay, let's do it.
That'll tell me what to do next.
Let's do it. First of all, I don't even remember how to build. So let's look at the docs and see, where are my docs again? I'm just gonna open up a new GitHub. README, details, development.md for details on how to set up your dev environment and start contributing code. Let's start there. Okay, initial dev setup. I did do this already. I haven't done this, so let's do that. I'm going to export that into my terminal. Actually, first, let me see if I have that binary. Go 1.11 RC1. Actually forgot. Yes. All right, so I had done this thing yesterday. Now I am remembering. So I'm going to export this into my terminal so that my entire terminal session will have it. So export that thing, and then let's make sure it's there. Let's just do this. There we go. Go binary path. Okay, so I got that. Services that Athens needs. Download and install Docker Compose. I have that. Run make dev from the root. Let's do that. Let me clear my screen here. Okay, cool. That looks like it's done. It does the minimum amount of dependencies to make things work, but if I want to do everything, run make all deps. I don't know yet if I need all deps, so let's just cross that bridge later if something fails. And then running the proxy or registry. I want to build. I don't really want to run. So let me come back to this. Maybe this is the thing that I should do, but I'm not sure yet. Run unit tests, make test-unit. What do you think, Carolyn? Should we run unit tests or should we try running the app?
I just want to try to run go build, to be honest, because as someone else pointed out, I think we forgot to clean up a bunch of references to app.
Okay. It doesn't tell me how to run go build, so let's literally just go in and run go build. How's that? Good. Okay. Yeah. So go build, clear my screen again. That's not the best.
How about go build .cmd/proxy? That's where you made all your code changes, right?
Yes.
All right.
Actually, I think, yes. There's a main in proxy, but I don't think there's a main. Yeah, there's no main here. Okay, so let's do it. All right, so main.go line 10.
Can we give points to our Primus for pointing this out? That
our Primus.
There we go.
All right. I wasn't watching chat, so if you guys have questions, interrupt me like Carolyn did.
Sorry, I'm bad at that.
No, you're good at that. I'm just going to keep talking. You guys have to keep listening to me unless you interrupt me. So where were we? Oh, yeah. CMD proxy main.go line 10. Main.go line 10. All right, that makes sense because now app takes in a storage dot backend. Okay. So like now the question is, what storage are we supposed to use? I'm going to go close some stuff so my head doesn't explode first. I'm really OCD about this. Good enough because I've got the two that I want to deal with here. So I'm going to go into app. We used to use this to get storage. So I'm pretty much just going to do that. I'm going to just copy and paste this back out to main. Because if it was good enough for inside of app, I am cross my fingers that it's good enough for outside of app. So let me do this. And I'll also copy that error checking code out. And then let's do this. Oops. Uncomment it. But since we're in
when you do really cool key combos like that, can you maybe call out what you're typing so we can learn how to do stuff like that quickly too?
Yes. Well, let me go back. I'm going to do this. I'm just going to like undo everything I did. Okay. So when I was in app, I'm on a Mac. So I pressed Command Shift and then the right squiggly brace. And that changed my tab over to the tab to the right.
Nice.
And if you use Chrome on a Mac, I think it's this by default. I think it's the same key combo. And then if I want to go left, I do Command Shift and then the squiggly brace, the left side squiggly brace to go back. So then now Shift Command right arrow. On a Mac, it's like that by default for every app, I think. And then also the default copy is Command C. And then I'm doing Command Shift left squiggly to go back. And then plain Command V to do a paste. Back to the right. I'm going to highlight all this stuff with Shift down arrow. Command C again to do the copy. And then now you guys are familiar with how to go left and right. So I'll copy that in. And now this is my favorite key combo in VS Code. By default, you can press Command / and it'll uncomment everything that you've highlighted. And then if you want to re-highlight it, Command / again. And if you want to get real goofy, you can highlight everything. If you want to get real goofy, you can highlight this, but then you can highlight more. And the stuff that was already commented is now double commented. And then the other stuff is single commented. And that's actually useful if you want to like comment everything out to start from like nothing. And then if you want to comment out like, or if you want to uncomment like some stuff like this, but maybe you forgot about all this stuff, you can actually do that. And then you won't accidentally uncomment everything. You'll just uncomment the stuff that you really wanted to. And that other stuff that you had previously commented will still be commented. So it's like, it kind of prevents you from being your own worst enemy, I guess. It's the best way to say it.
It looks silly when you do it for code that's commented out, but I think it makes a lot more sense when they're text comments. Like,
yes.
So if I made a text comment and then selected a whole bunch of stuff and commented it all out, and then I introduce it back, I don't accidentally like strip the slashes off of a real comment and make uncompilable lines that have English in them.
That was like a million times better explanation than mine.
I also like, if you can't remember the shortcut keys to it, you can just go Command P angle bracket and then type add comment or something like that, and it tells you the shortcut key for that thing. Or you can just run it from the command palette. And if you jump it,
angle bracket.
So it's command angle bracket.
Command angle bracket. What am I doing wrong?
Oh, sorry, Command P and then angle bracket. So Command P to bring up the command palette, angle bracket to get you into the commands.
Oh.
And then you can type add comment. So if you just type comment, it'll probably be there.
Add line comment.
And then that shows the,
Whoa.
And then that runs that command. And you can do the same thing for like run text in terminal. If you're like in text, or if you're on a line of text, you can go Command P angle bracket terminal, and it'll show like run current line in terminal or that kind of thing.
Cool.
And for jumping between tabs, I also like the control and then the number, the digits, because that'll jump it to like tab 1, 2, 3, 4, like it does in Chrome. Except in Chrome on a Mac, it's actually command 1, 2, 3, 4. So those are the kind of things I use for tabs on Chrome and in VS Code.
I might have that one turned off because this is, oh, no, I don't. Oh, that's really cool. Now I can go to my first tab and my OCD can kick in. I'd be like, nope. Third tab.
For jumping between source files, I typically go Command P and then type the name of the file. So it'd be Command P download.go, and I use that. And then
that's cool. Nice. Okay. Another one that I like.
Oh, sorry.
Go ahead.
I was gonna say, I almost want to have like a study group topic that's just cool tricks like this. So I apologize. I know I just slowed you down a ton in what you're intending to show. But
Hello.
okay, I'll type it in there. I'll put it in.
Type it in there. Another one I like, to your point, Aaron, is Command T. And then if I have like, this is for like symbols, I guess. So if I have like new storage, it takes its time, but then I can see all the functions called new storage. And I actually like this specifically for storage because we've got all these different implementations of storage. I can kind of see them based on the package name. So it's like, oh, hey, what kind of storage drivers do we have? All right, well, we've got Mongo, in-memory, Minio, file system, Olympus, whatever that is, RDBMSs, and that looks like just about it. So it's like at a glance, like I don't have to go over to the file list. I can just kind of do Command T, and if I'm wondering about what is this function all about, I can just see it in the list, but then I can press enter and go jump to definition too.
That's really interesting. I've actually never used that Command T with the hashtag. How does that differ from Command, let's say go Control Command P @ symbol? Is that a similar? Oh, that's okay. So that
I've never even seen this.
So that's what I use for jumping between functions and members. But what you just listed was a much more comprehensive list. It seems to be across all the packages or something.
Yeah, I didn't even know this existed. There's lots of goodies, I guess. I use Command. I actually discovered the real use of Command T because I used to do Command T, and then I would always delete the hash so I could go to a file. And then I discovered Command P to go to a file, like you told me about, Aaron. And then I discovered what happens if you do Command T but you don't delete the hash. And then I was like, mind blown. I've been doing it all wrong this whole time.
That is great.
All right, let me get back to main now. So main, I had copied this stuff in, and I remember I have to pass the storage to this now. So yeah, let me uncomment this stuff. This is again that command /. So we've got our store. We're not really handling the error super well. This is actually going to do a compile error. So let me save this and go back to go build. And two things. First is that, and then the second is on that line 14, I'm returning stuff, but main doesn't have any returns. So we got to figure out how to report that error better. But let's actually deal with this first. So line 11. Here, get storage. I copied that right out of app. So like here, where was it? Right there, it was calling get storage. So let me actually uncomment that and then jump to the definition of it. So get storage is still inside of CMD proxy actions. So it worked with app because that was in the same package, but it's not going to work outside of there because it's not in the same package. So all I got to do is specify the package. Fairly straightforward. So let me build again, make sure that was fixed. Clear the screen here. Cool, fixed one. This is saying I'm trying to return nil and an error, but the function signature says I can't return anything. That's fair. And since this is like the top level, I'm just gonna like copy what other people did. So here, log.fatal. I'm just gonna do the same thing. So we've got a nice error message here. So let me just log.fatal that error message. And we can't return, just like the compiler said, so I'm gonna do that. And now let's try it. I think we've fixed everything, so cross your fingers. No, app declared but not used. Command proxy main line 16. Ah, that's a problem. I don't even know why this is commented out, but app.serve sounds pretty important because that's probably serving the web app. So let's uncomment that. And same deal, when we get an error back, we're just gonna log.fatal. It seems like that's the pattern in this function, so I'm just gonna stick with the pattern. Now let's try another build. Oh yeah. Okay, so that's a good start. We can build, but can we test? Let's see if we can test. Let's start by doing this. Go test CMD proxy, and then I'm gonna do ... If you're not familiar, this is testing everything in CMD proxy and all the packages below it as well. So it's basically everything that you see here, starting with actions all the way down, and including recursively down any directories. So basically any file that ends with _test.go and has a func test blah, blah, blah in it that conforms to the Go standard library. So this one, let's see. All right. CMD proxy actions list test line 26. We were just working on that, so let's go in and see. This is a fancy thing I like with iTerm, by the way. If I press Command and then hover over one of the files, it does this incorrectly for packages in Go. But with files, it correctly does. If I do command and then hover my mouse and then click, oops, it actually works and it takes you to the right line. So just try again because I think I messed it up. Yeah, so it takes you to the right line. That's nice. I like that.
Is that a code thing? Is that an iTerm thing? Did it know to use code because of your editor setting? It's magic.
It's an iTerm thing by default to like find. It does this for file names and both relative file names and absolute. So since this didn't have any kind of like absolute slash in front of it, it assumed it's under that directory, under my current working directory. But it also does this for URLs. So like if it's google.com, I can just command click and it'll open up the default browser. And then
so code is your default editor.
yes, that was gonna be, yeah.
Okay.
For Go files, iTerm just calls out to standard open, like OS 10's just standard open file. So essentially it's doing the same thing as what I'm about to do.
I think VS Code does something similar from its integrated terminal, even if it's not the default editor.
Oh.
But I could be wrong.
Well, let's try it. Go test / ... And I'm going to try to make this bigger too. Yeah, better. Let's see. Okay, so then, so I can click on this, Aaron?
Yeah, command click on it.
Well, there's some cool stuff here. Command click.
Does it jump to the file?
So if my editor was like something else, would it open in that editor too?
I'm pretty sure because mine's not the default for the Go, and I think it usually did that from the terminals.
Cool. All right. Well, that's awesome to know. I like iTerm, so I'm going to stick with iTerm for now. I'm really trying to get more into the VS Code terminal, but for some reason my mind can't like grasp having a terminal on the same thing as a text editor. I don't know why. But this is really good to know because sometimes I end up in here anyway. Okay, so the error. Missing a comma before the new line, line 26. So that's fair. Go always makes you put a comma even if there's nothing after it on the next line. And I can already see there's going to be another error, but let's actually compile and see. Go test. Alrighty, there's some crazy stuff. Mixture of field :value and value initializers, undefined zip, blah, blah, blah. All right, so line 26 again, undefined is zip. That is true, we didn't define it. If I remember correctly, zip is an io.reader. So I am going to actually use my getReader call, my new function, a.getReader. Okay, better. And what else was left? Info. Byte, and then 4, 5, 6. You know, actually, I'm gonna take that. I keep typing like slice of byte, parentheses, whatever. It's not a huge deal, but I don't really love it. So I'm gonna make another utility function for that. Call it byte slice. Same deal, it's gonna be 1, 2, 3, 4. I think eventually I'm gonna wanna make these random byte slices because it'd be cool to have like the mod different from the info. But this is a place to start, so I'm gonna just start here. So replace those with a.byte slice. That one too. All right. So we got one version. Oh yeah. Then this, let's try this again. Okay, no new variables on the left side on line 32. Okay, I think we had another error on line 32 as well. cannot use string slice literal as type test case slice in assignment. All right, so these are related. The first one is saying that I already declared versions. And then the second one is saying, oh, well, if you wanted to reassign versions, you can't, because versions is already a test case slice and you're trying to now say it's a string slice. So either way, there's two errors that really can be fixed by deleting the second one. Okay. And now,
Aaron, I'm going to give you a time check. And by time check, I mean we're at 1 o'clock.
Thank you.
Or end of the hour.
Thank you. All right. So last thing, I'm going to run go test one more time. Yeah. All right. So 2 more compile errors. This thing is going to be up on that pull request that I will put into, that's already in there, I think. Yes. No. I will put it right here after the meeting. I'm actually working on that. I'm going to try to get it merged this week so you can watch it and keep up with it. And I'll probably screencast it as well on this same playlist. So that's it for today. And I am going to put some more stuff for myself onto the agenda for next week, and you guys should do that too. So you actually definitely should do that so you don't listen to me live code for an hour. All right, everybody.
Thanks for letting us watch you code, Aaron. It was fun.
Thanks for coming, everybody.
Yeah, thanks.
Thank you.
Fantastic.
Yeah.
Bye-bye.
Bye.
Hey, Aaron, how do you feel about doing a VS Code for Go overview?
I think that sounds like fun.
Okay.
Maybe let me think about what is next week. Not sure about. I'll think about next week, but definitely either next week or I guess the week after GopherCon. But
Yeah. Okay.
I think it's really cool. I learned a whole bunch. I'm not sure if you saw the chat, but I saw that that Command T thing is actually show all symbols in the entire project. So it goes through and it like gathers them all, and I never knew that thing existed.
Awesome.
And then the Command something O is go to symbol, which I guess searches dynamically. So that must be why it's it's a tad faster.
Nice.
There is so much in VS Code for Go, and this was I really enjoyed this. It was fantastic.
Cool. All right. Well, I will talk to you soon then about that. More VS Code nerd sniping.
Sounds like fun.
All right. See ya.
See you in a bit.